Right, hi everyone. My name is Clara, and today I'm going to talk about some of the work that my co-worker Clara and I have been doing at Chamber Labs to mitigate jamming attacks against the Lightning Network. Now, this is a technical talk, so it assumes basic understanding of the way the Lightning works and some familiarity with the problem of channel jamming attacks. So we're only going to spend one slide on background and terminology. It's hacking a lot. And then the rest of the talk will really go into the details. So as we know, the Lightning Network is vulnerable to a denial of service attack, which uses failed payments to consume the resources of a forwarded node. Right? This will either be its liquidity or the slots that it has in its channel. And if you can successfully do this, you can render a node incapable of forwarding honest payments, which means they also can't earn any routing revenue. When you choose to do this, there are two ways that you can go about it as an attacker. The first strategy is a fast jamming attack, which is to send endless streams of fast-failing HTLCs through a channel occupying all of its resources. And this is difficult to detect because there is some natural rate of failure in Lightning. We do expect some payments to fail, so it can slip in with regular activity and it's quite difficult to identify. That's the right word. In contrast, you can also do what's called a slow jamming attack. So this is when you send and hold a set of HTLCs on a channel right up until the point of on-chain failure, but then quickly fail them back before ports being force closes. And these are much easier to identify because they're kind of obvious. In today's Lightning Network, things don't really get stuck anymore. So if something is going slowly, it is quite easy to identify that atypical behavior. Now, the barrier between these two things is not very rigorously defined, but for the purposes of this talk, we'll think about them kind of in these two classes. Now, I know that many of you have heard about jamming attacks against Lightning for as long as you've heard about Lightning, right? It doesn't really even feel scary anymore, it just kind of feels like the way it is. But I really just want to say that this is something that we desperately need to fix. This is urgent, because Lightning cannot do what it's supposed to do if any node or any route along the network can trivially be taken down by an attacker with almost no expense. So we do need to stop jamming. And we have tried, we've talked about this for about 6 years now, coming up with various different solutions, but nothing that we've thought about so far has made it across that finish line of merging mitigation for channel jamming attacks to the Lightning specification. And what we've thought about so far can be roughly classified into two classes of mitigations. The first one is monetary, where we require an attacker to pay for the resources they consume. And the second one is reputation-based, which requires an attacker to build a history of good reputation or good behavior to get full access to your resources, and then if they misbehave, that access is slashed. And in isolation, neither one of these has really managed to fully address the range of attacks that we think about when we think about channel jamming attacks. When we think about monetary issues, we run into pricing problems. So how much are we going to charge for these HTLCs and misuse of our resources? This is because, in large part, we have a massive order of magnitude difference between the amount of time that an honest payment will take to resolve, a matter of seconds, and the amount of time that a dishonest or a slow jamming payment can take. It can be held for up to 2016 blocks, which is a very long time, it's about 2 weeks. This long hold option in Lightning also isn't going away because the CLTV delta is a security parameter that allows nodes to trustlessly settle on chain. So if anything, it will get bigger as congestion on the base chain rises. And finally, we also don't have an option to cancel early. You can't accept an HTLC, forward it on, and think, oh man, someone's jamming me, I want to cancel it back. That's not safe because then money can be pulled from your node because you don't get to claim both sides of that interaction. So for monetary issues, we also either need an upfront commitment because when an HTLC is committed to, you don't know how long it's going to take to resolve, or we need a continuous stream of money, which the complexity of that just completely blows up as like an implementation detail. Just to give you an idea of how bad this order of magnitude problem is, if you have a regular payment, it takes a few seconds to resolve, you're going to charge 1 sat of upfront fees, right? It's less than 10 cents, the 10th of a US cent, doesn't really matter. Scale it up to 2 weeks and it costs $312, which is untenable in Lightning to today, right? That is not an amount that we can charge someone as an upfront fee for a payment. And so we end up with this issue of trying to set a price for this large spectrum. When we sit at the bottom, we end up with prices that are too cheap to dissuade attack, and they do not properly compensate nodes that are targeted. But if we look at the other end of the spectrum, when we do want to fully shut down on this slow jamming attack, we end up with solutions that are far too expensive for honest users. So we can't comprehensively address jamming with monetary solutions alone, right? They just can't cover this full range in a way that doesn't decimate the user experience of Lightning, which is certainly not what we want. And when we look at reputation systems, generally they are gameable, right? Because when you create a reputation algorithm, you have to set some definition of what bad behavior is. And no matter how intelligently you do this, someone can always work just around your reputation system. So if you think about resolution time, oh, I need an HTLC to resolve in 10 seconds, someone will make sure it resolves in 9 seconds. If you say I want all of my forwards to at least a 40% success rate, a node can very easily just spin up multiple identities in the network and have all of them sitting just at 40% success rate and continue to spam. And these edge cases are very difficult to detect because they are inherently falling just underneath the thing that we're looking for. And they also can happen to honest users, so even if we can detect them, being able to harshly punish them is also going to harshly punish honest users in some cases. So instead of trying to find one solution that addresses fast jamming and slow jamming and does so in a way that doesn't hurt the user experience too much, we propose a hybrid approach. Why not use both? This was originally proposed by my colleague Clara and Sergei Tikhomirov in the 2022 paper, and I'm currently working on the specification and implementation of this video. And that is that we use reputation systems to address all of the jamming attacks above some threshold. We know that we can identify these because the HTLCs are resolving slowly, and we can effectively use reputation to shut them down. But as we discussed, there is some threshold underneath which the reputation system won't work because we can't detect that sort of last little gap. So what we do is we fill that in with a monitoring approach to close the gap of the reputation system. And this is really nice for a few reasons. First, because we can address the weakness of the reputation system that is inherently not that effective beneath the threshold. But it also narrows the range of pricing that we need for our monitoring solutions. So when we can set this threshold like pretty low, we don't need to account for that large range of pricing options in the monitoring solution. Now, I know that no one likes upfront fees. I know that it's a terrible thing, and I know that Lightning user experience is hard. But I want to reiterate a public service announcement that Rusty made in 2019. And this is that fees will rise and slow HTLCs will suffer. But we cannot allow this free relay of payments in the Lightning network. We are going to need to solve this spamming issue, and a component of solving this spamming issue will be monitoring. Now, I am not going to spend the rest of the talk on upfront fees because the piece that we're looking at first is reputation, but if you'd like to chat about it after the talk, we're pretty confident we can get this down to as low as 1%, and with protocol changes like asynchronous payments, we think that we can mask a lot of this unconditional upfront fee with intelligent retries. But I'm going to spend the rest of the talk thinking about local reputation, and when we think about this in Bitcoin, we have to first think about privacy. And specifically, we have to ensure that we preserve the existing privacy guarantees of Lightning. Lightning privacy isn't perfect, there's lots wrong with it, but we cannot ship something that makes it worse. We're really engaging in an uphill battle to fix it all. And what this means is that we are only going to be looking at local reputation for Lightning nodes. And to strictly define that, it is reputation that is sourced only from interactions with your direct peers. That is the only input to the system. It is not shared, it is not passive, it is purely held locally. And you are only concerned with the reputation of your direct peers. You do not care about the reputation of the original sender or of the eventual receiver, which was a feature in some previous reputation schemes. The other thing we need to think about very carefully is how a reputation scheme could act as a centralizing force in Lightning. And this is very difficult to quantify because you can't really put a number on centralization very easily for a proposal. So what we've done is we've made some qualitative statements about what we'd be worried about in terms of centralizing force, and then talk about how a solution can get around these things. So the first concern you would have is that nodes that are looking to protect their great stellar reputation will drop payments from nodes that are new to the network or nodes that are so infrequently used that you just don't have enough data points for this, right? And this is really bad because it discourages people running their own nodes. It maybe, puts some Raspberry Pis out of the running, and it forces people towards centralized services to have more reliable payments. So the way we can get around this is to de-risk the forwarding of unknown payments. If there's a way in the system for you to forward a payment without your reputation being affected by the outcome of it, you have no incentive, no disincentive not to forward. You're still going to just forward it because you could earn some fees, and your reputation will be unaffected. The next thing we need to think about is barriers to entry for new entrants, because that's what keeps Lightning decentralized, and keeping decentralized is what keeps us censorship resistant. And the way that we can get around this is to ensure that we provide new nodes, so new entrants to the network, get immediate quality of service, and we provide them a clear path to bootstrapping, which includes no actions that they wouldn't already be taking as a node. And finally, and probably the most scary and malicious feeling one, is that if some surveillance company decided that they were going to start gathering data about Lightning nodes and selling reputation as a service, meaning that you can't really get a payment through without their great service. And the way that we can address this, and the biggest claim that we make, is that we need to ship a reputation system that has no impact on the steady state. The steady state being Lightning as it is today, no one is attacking us, everything is running. And if it has no impact, this means that a node that has no reputation score and a node that has built up a reputation score experience no difference in their quality of service when the Lightning network is operating as usual. Because if we can do this, we can decrease the economic value of creating such a service and undercut the incentive to make one in the first place. And to do this, we need a little bit more than local reputation. We have a combination of things that I call local resource conservation, which I'm pretty sure was the prize for the driest name of Bitcoin, but I couldn't think of anything better. So we have local reputation, which is our local assessment of how our peers behave. And we pair that with HTLC endorsement. And this is a very simple mechanism. It's just a 1 or 0 propagated along with HTLC that indicates whether a node is willing to stake their reputation on that HTLC. So if it's set to 0, you say, hey, I don't really know what this is, but I'm forwarding it, please don't punish me. And we take those two things as inputs and we implement them in a system that we call resource bucketing. And what this does is allows us to ensure that there is no impact on the steady state because we sort of align our resources with these two inputs. So what HTLC endorsement looks like if Alice is sending a payment to Dave is that Alice will endorse her HTLC as a sender if she thinks that the recipient of this payment will resolve it quickly, right? It's a normal Lightning payment. It's not a swap, it's not a DLC, it's not something funny. I'm sending a payment, I think it's going to behave as usual, I'm going to endorse it. Now, she can set this value to 0 at some probability to make sure that she doesn't instantly out herself as a sender. And we would suggest that people match the endorsement patterns that they see for HTLCs that they forward on behalf of other people to be able to mask themselves within that traffic. Now, when it comes to forwarding nodes, you do a bit of a different calculation. So when Bob receives this endorsed HTLC from Alice, he will endorse the outgoing HTLC if the incoming one was endorsed and the peer that sent it to you has sufficient reputation or has good reputation. So in this case, say Alice does have good reputation with Bob, he will forward it on to Carol as endorsed. Now, Carol has just met Bob, or he hasn't built up sufficient reputation yet, so even though he has endorsed this HTLC, he's not a peer that Carol is familiar with, so she will forward it on as unendorsed. And when she forwards it on unendorsed, it also will hit this resource bucketing, which splits payments for the endorsed and unendorsed payments. And you can kind of intuitively think of this as a web of trust. I won't use that term too much because I'm not deeply technically familiar with it, but you sent me something, I think you're okay, you think it's okay, I'm going to forward it on and I'm going to say it's okay, right? That's the intuition behind it. But I really want to underscore the importance of adding this mechanism because it allows us to provide many of those guarantees that we talked about earlier. The first one is it allows us to facilitate unknown traffic. because when you send an HTLC which is not endorsed, you're saying, please don't dock my reputation, but I'm still forwarding this because I want to be able to serve traffic. The next is that it also helps peers to be able to bootstrap, because when they show up, they don't have reputation, but their payments will still be forwarded as unendorsed, and they'll be able to build that reputation. And finally, and very importantly, it also allows us to limit the sabotage that remote peers can attempt to mess with our reputation. So if you have a channel with a peer and you've got good reputation, if someone shows up and starts spamming payments through you to your peer in an attempt to trash your reputation, if you set endorse to 0 because you don't know who they are, they can't actually negatively affect your reputation, even though they're trying to do so. Now, the next piece of the puzzle is the actual local reputation algorithm. How do we decide when someone has a sufficient reputation? And the way that we think about this design is that we want the cost of acquiring reputation to be greater than the damage that you can inflict if you abuse that reputation. And the reason we're going for this is that we think it's entirely likely that people will try to build reputation and then try to use it to attack you. But if you've already paid us what we would have lost in that attack, it's sort of zero-sum for them, right? They had to pay us all this money and then they made us lose the same amount of money, so what was the point of doing it in the first place? And we think about this reputation score on a per channel basis. So when Alice forwards to Bob and says, I want Carol, I want to forward back over Carol's channel, that is the channel that we look at. So the cost of acquiring that reputation will be all of the payments that Alice has forwarded to Bob as an incoming link. We only do this in one direction because those are fees that Alice would have had to pay if she was the attacker, right? That's actual money in the bank that she's paid us. It's not a forgeable metric. But when we think of the damage of the attack, so what could happen if our outgoing channel was completely jammed? What happens if we get attacked and this channel is rendered inoperable for that 2016 block rate, right? What is the damage that we would experience as a node? And that is the bidirectional traffic on that channel, because the channel is valuable in both directions in Lightning. So we consider all of the fees that we've earned over that period that we could be slow jamming attacked as the damage for that node. We also need to think about in-flight HTLCs, because in reputation systems there's a big problem with two-faced attacks. So you can reasonably expect an attacker to behave absolutely perfectly and then turn around and try and jam you. And we need to be able to account for in-flight HTLCs so that we don't let someone get to that threshold and then just fill our entire channel up. And we do this by simply docking reputation by a risk factor for that HTLC. So once it arrives, we preemptively bring them down, and then once it settles back, they'll go back up to where they were. So the final equation is, on the left, the fees that you have forwarded, you will be considered to have good reputation if the fees you have forwarded me, less the risk of HTLCs that you currently have in flight on my channels, is greater than the bidirectional revenue on the outgoing channel over the last 2 weeks, which is the period of time that you could theoretically jam me for. So taking this one by one, when we look at the fees that you've paid us as an attacker, we don't just look at the fees piecemeal, so what you forwarded us with the HTLC, because we want reputation to force attackers to mimic honest actions in the network as closely as possible. And the reason for this is that we don't want to provide an advantage for malicious bootstrapping. If someone is building reputation with the intent to turn around and attack us, we want them to, as closely as possible, have to mimic honest nodes, because we do not want them to be able to gain an advantage over honest nodes by taking funny or special actions, right? They can only build up their reputation as fast as everyone else can build up their reputation, so they have no leg up over the nodes that are just doing the right thing. And the way that we do this is we define an opportunity cost function for slow resolution, right? And this allows us to capture what we consider to be desirable behavior. So we set a threshold. We're going to say that we think that 90 seconds is a pretty reasonable amount of time for a Lightning payment to resolve in. And then if you resolve within that period, that's fine. There's no opportunity cost. We did what we wanted to. But for every 90-second period after that first 90 seconds, we will charge you the fees for that HTLC as an opportunity cost, because you used up more than that one slot that we gave you, and we could have been forwarding an HTLC in every single one of those slots that you consumed because your payment took too long. So then in the example, we take 900 seconds, so 10 times the amount of time we think you should. You will be charged 9 times the fees, right? The first period is free because that's fair game, that's the amount of time we think you should take, but then you are charged for the remaining 9 periods that you took up as a HTLC. And this will input into what we call effective fees. So when we are calculating the reputation score for a node, we'll go through each HTLC they forwarded through us, and we will calculate this effective fee. And that also depends on the HTLC endorsement signal, because as I said in the past, endorsement means hold me accountable, or hey, I don't know what's going on. So in the case where an HTLC is endorsed and it was successful, we will give you the fee to contribute towards your reputation because you forwarded a good HTLC. But we will subtract the opportunity cost. So if you took more than 90 seconds, a successful payment can actually still negatively affect your reputation. Because if you send us a payment and it takes 2 weeks to succeed, that's not a good thing. That's not good behavior in Lightning, even though you paid us a little bit of fees. When it fails, you didn't pay us fees at all, so we just subtract the opportunity cost. And then in the unendorsed case, it's a bit different because these HTLCs, you already know how they're going to resolve. So all we care about is, did they succeed quickly? Did they succeed in 90 seconds? If they did, we assign the fee that you paid us because we want new nodes to be able to bootstrap, and this is how they do it, by forwarding unendorsed payments through, and hopefully they succeed and they can bootstrap their reputation over time. But if it didn't succeed quickly, you told us you didn't know, it didn't go well, that's fine, your reputation is not impacted. The next thing we look at is in-flight risks, which is, as I mentioned, the way that we dock reputation preemptively when you have HTLCs in flight, because we worry that they will be used to attack us. And so we reuse that opportunity cost function that we defined in the previous section, but we don't know how long this thing is going to take to resolve yet, so we use the HTLC's expiry. It's going to expire in so many blocks, we assume 10-minute blocks, and we put that into our opportunity cost function. So we penalize you very heavily for this. We do charge you, right? We dock you down, and then we accept the HTLC, and then we see what happens, right? Maybe you attack us, maybe you don't. And this is okay because for regular payments, things resolve quickly. Your reputation drops down, a few seconds pass, it drops back up, and you're back in the good books. However, if you do use this to attack us, we've dropped you down, you behave badly, our outrageous fears have been realized, but you're already sitting down there, we don't restore your reputation. The last piece of the puzzle is very simple, so your target channel revenue. This is just the routing window, so those 2 weeks, which again is defined by the longest number of blocks from the current height that will allow HTLC to expire at. So this is how long this thing can sit here. And then all we have to do for our routing revenue is define sum up the bidirectional routing revenue on that channel. So that side is very easy. First side, not so easy. And we wanted to get an idea of what this algorithm looks like. So we spent a lot of time creating some synthetic data, running Jupyter notebooks. This will give you an idea of how it operates. So the orange line is the reputation threshold. For a node, we have other payments that are not related to the sender. So we've simulated activity and then we're looking at one node. And then the blue line is your reputation. You can see how it starts to build, it drops down when HTLCs are in flight, but it pops up pretty quickly. And eventually, over time, reputation accumulates and crosses that reputation threshold. And we've done a bunch more of these, and we have slides available if anyone wants to take a look at them. So,
why was the threshold changing over time?
Because we generated this activity, so like thank Alice, Bob, Carol. The Bob Carol channel is forwarding different amounts of payments, some random walk, so like it goes down when the channel is less active and goes up when the channel is more active, right? So it's just like a tracking average over time. The last piece of the puzzle is resource bucketing. And what this does is it basically divides our channel into 2 logical channels. You assign some portion of resources. I'm going to talk about slots, but it's slots and liquidity. You do this for both of them. You assign them to be protected, right? Which means that these resources are reserved for HTLCs that are endorsed, and they come from peers with a good reputation. And you can think of it just like a normal channel. If all of these resources are exhausted, payments will start to fail. And then our second logical channel inside of our channel is our general slots, right? And these work exactly like Lightning works today. Any payment that is not endorsed or doesn't come from a peer with good reputation will go into this slot. And there is intentionally no barrier to entry because we want to accommodate newcomers and infrequent users of the network. This is a very important piece of this. Without this, we are going to end up blocking some people from being able to use Lightning. And in the steady state of the network, so as it is today, no one's attacking me now, we don't really expect this to have much of an impact on routing. We expect HLCs to arrive and resolve and be sorted into their buckets, but never really need to be dropped. And this is because payments in Lightning resolve very quickly. So even though a channel with some capacity can forward 10 times that capacity in payments, at any one moment in time, the channel is not saturated. It's not got that much in it. It's never full. And we have sanity checked this with a few folks running some of the biggest nodes in the network, and no one sees more than 15 HLCs at a time, right? Things clear quickly, business as usual, so we don't actually care about the difference between these two things. But when we're in the attack state, so if someone decides they want to try and attack us, we can expect this general bucket to fill up because there is no barrier to entry. This is intentional. They can fill it up with fast jamming HLCs or slow jamming HLCs, but they will be able to consume these resources. And in this scenario, when someone is attempting an attack, payments that are not endorsed or do not come from good reputation peers will not be given resources, right? That general bucket is full, and we will have to fail to pay them. And this does mean that when the network is under attack, new and infrequent users will experience a greater quality of service while the network heals and cultivates. However, we do have these protected resources, and an attacker cannot encroach into these resources because to do so, they have to endorse an HLC. If they endorse an HLC and they try and attack us, we immediately dock their reputation. So they cannot move into these slots. And then when payments on the network arrive, regular, honest payments that are endorsed, and they come from good reputation peers, we can add them to this bucket and process them as usual. So the network maintains its ability to forward honest payments from active nodes, from nodes that have achieved good reputation, and it will temporarily experience a degrading in service for new and infrequent nodes. And in this way, we can still preserve the ability for the network to make payments while it's under a jamming attack. Now, it still sounds very good, but it's one thing to think about it, it's another thing to know how it works. So we are trying to be intentionally data-driven about this work. So the first thing that we've done is produce Jupyter notebooks with synthetic data where we see what this output looks like, we look at the edge cases, we look at its behavior under attack. And we've done quite a lot of that, and we feel good about what we've got. We feel like if the synthetic data is realistic, this thing is behaving exactly as we expect it to. The next piece of the puzzle is to spin up some simulations, some break test nodes, running the full thing and see how it behaves under attack. We're aiming to pre-command some attack scenarios where we can compare a non-attack state to a regular attack state, and then compare those two, and even provide people with the ability to think out their own attacks if they're happy to do that. And finally, we also want to do some mainnet data collection. We posted some main lists before, trying to make sure that everything that we are assuming and everything we're thinking about actually does correlate with reality. And this is where you can help. If you're running a Lightning Network node, we are looking for volunteers. I'm going to put this QR code up. If you want to scan it, give us your email, we'll reach out to you, give you some details. Yeah, Jamal, scan it. But this is a cross-implementation effort, which is really nice in Lightning. Sometimes it's scarce to see. If you're running attendee, I've got some PRs open on Circuit Breaker, which is a companion program which allows you to track this information. If you're running CLN, Vincenzo's Allen Metrics plugin is doing the same thing. And if you're running a Clara, that's quite nice because they're doing it in-house, so you don't actually have to run anything additional. And we've defined a common data format, so each one of these PRs, these projects will output the same data format, which allows every team to produce their own tooling of a common base to help think about this problem. And what I'm going to do is talk a bit about Circuit Breaker, because that's the one that I'm working on, and we want to be very conscious of the fact that this is sensitive data, so I'm going to tell you exactly what we're going to be doing and exactly what you will give to us to help us achieve this. So the first thing we will do is we're going to collect granular HLC forwarding information. And this is just because we don't have all the timestamps that we need available to us right now. Lightning nodes try and run quite lean, so they don't store the resolution timestamp, and we don't have an idea of how quickly HLCs resolve on our channels. So we're just going to store that in the database locally. We'll then provide tooling for local static analysis, so you never have to send this data to us. We will just provide you a tool that you can run on the output of that previous step, and it will help us get an idea. And what you will give to us is the aggregate slot count, so the number of slots that are being used in any instant in time, and the aggregate liquidity usage, which is the amount of liquidity that's being consumed. And this will help us sanity check our hypothesis that resource bucketing will not have an impact on the steady state, and it will allow us to find a way to set sane defaults. The next thing we will be looking at is the percentage of your peers that manage to consistently achieve good reputation. And this is also very important because we need honest actors to be able to achieve good reputation, because only the nodes that achieve good reputation in the system are the ones that are protected. And finally, we're also going to run what we call a log-only version of local resource conservation. So run the whole thing, see what it does, and provide some aggregate report to us so that we can understand the way this algorithm behaves with real-world data. So that's it. That is how we plan to stop channel jamming. I know it feels like a marathon already, but we can fix it. We will fix it, and you can help us fix it by running data collection on your node. Thank you very much. Questions, if we have time.
Yeah, we can probably take a couple.
Let's see, have you considered non-malicious usage of like hot invoices, for example, which we use for our channel marketplace? Yeah, have you considered non-malicious usage of HODL invoices for long-term HTLCs? And then the second part of that is, have you considered like the liquidity usage of that as maybe a mitigating factor that this is real-world usage for escrow?
Yeah, totally. So I think there's two pieces to that. The first is that if you are doing something on Lightning that requires a long-held HTLC, in this system, you will not endorse it. As we believe that this system will have no impact on the steady state, you can just send the payment as unendorsed. We expect it will go through, and it's totally unaffected. But the larger question is Lightning going to be predominantly used or like very widely used for these long-held use cases, right? If we see DLCs on Lightning, if we see different sort of things entering the network, and if that is something we choose to introduce Lightning and sort of spec out, we are going to have to change the way we price things. We would maybe flag an expected hold time, include an extra fee, price by some time lock, but if that's a use case that is going to remain in Lightning, it will be treated as a separate type of payment. Possibly we can have a third bucket, right? 2 buckets is nice because it's very simple. We can have a long hold bucket, and nodes can decide and price how they are going to say, this is my long hold bucket, it's more expensive because you're using things for longer, but that'll just be baked into the fee structure of Lightning eventually.
Any other questions? Can you come up here?
I assume if you want the reputation system to work, we need a sufficient amount of nodes which will actually send the reputation. Because if you want that your entire reputation can travel across the payment paths, everyone needs to implement it. Do you have an idea of what percentage of Lightning nodes needs to support it to be somewhat useful?
In terms of that signal propagating across the route? I'm going to implement an attendee, which means 80% of the network will do it, so that's kind of my dumb answer. My smart answer is that there is an incentive to implement this, because if you don't have it, everything you have is unendorsed. That means all of your users, if an attack does arrive, they are in trouble, right? They can still build a little bit of reputation, that's really nice, because even if they don't know this thing exists, when the field doesn't arrive, we say, oh, it's 0, and we give you reputation. even though you have no idea. But I think that, I hope that everyone's incentive is to not get wrecked, so everyone will just do this. And this is really light. What's so nice about this, like, the endorsement field is 1 TLB. The reputation code is like 600 lines of Go, which is probably like 3 lines of Rust. And the resource bucket is pretty light as well, so it's, yeah, we'll see. Here we go.
We